Okay, so look at this. Left side, the demo. One agent, one tool server, clean connection, green check mark. Beautiful. Every tutorial you've ever watched looks like this. Now look at the right side. That's production at 3 a.m. Multiple agents, multiple tool servers, database nodes, queues. And what's happening? Server crashed silently. Connections breaking. And here's the worst part. The agent is hallucinating lost tools. It doesn't know the server is gone. It's just making stuff up. This is the gap nobody talks about. Multi-server environments break naive implementations. They just do. And if your AI agent doesn't have infrastructure that survives failure, you don't have a production system. You have a demo that got lucky. Today, we are fixing that. I'm walking you through the MCP Hub architecture, the layer that makes multi-server AI agents actually resilient. Let's get into it. All right, first, why does any of this matter? Because of this fundamental problem right here. Your LLM, doesn't matter which one, GPT, Claude, Gemini, is brilliant. But it's trapped inside a context window. It cannot query your databases. It cannot check external APIs. It's utterly isolated. Without a universal protocol to connect this brain to the outside world, every integration is custom. Every tool needs its own connector, and that doesn't scale. So the question becomes, how do you give this brain hands? How do you let it reach out and actually do things in your systems? That's exactly what MCP was built to solve. And here's how MCP solves it. Look at this diagram carefully, because this is the core insight. Left side, the M times N nightmare. You've got 3 LLMs, 4 tools. Every LLM needs a separate custom integration to every tool. That's 12 connections, each one different. Each one you have to build and maintain. Add one more tool, 3 more integrations. Add one more LLM, 4 more. It explodes. Right side, MCP collapses this to M plus N. You put the model context protocol in the middle as the standard. Now each LLM connects to MCP once. Each tool connects to MCP once. 3 plus 4, 7 integrations instead of 12. And it stays linear no matter how many tools you add. This isn't theoretical. MCP standardizes how agents discover and call tools. It exposes them as callable functions automatically. And it's battle-tested. 97 million monthly SDK downloads. OpenAI adopted it. Google adopted it. Microsoft adopted it. This is the standard. Okay, so MCP solves the integration problem. But now you have a new problem. You're in production. You've got an inventory server on port 9001, 4 tools. Payment server on 9002, 4 tools. Notification server on 9003, 4 more tools. 3 servers, 12 tools, all running independently. Now, who tracks which servers are actually alive? Who tells the agent when a new server comes online? Who detects a midnight crash? In most setups, nobody. The addresses are hard-coded. The agent assumes everything is always available. And when something goes down, it either crashes or hallucinates. You need a component whose entire job is answering these 3 questions. That component is the MCP Hub. But here's where people get it wrong, and I see this constantly. The instinct is route all tool calls through the hub. Agent calls hub, hub forwards to server. Makes sense, right? Single point of control. Also, a single point of failure. Look at the numbers on this slide. The latency tax, 30 to 50 milliseconds of pure waste on every single call. Your agent makes 6 tool calls in one conversation. That's 300 milliseconds your user is sitting there waiting for no reason. But here's the fatal flaw. If the hub drops, and things drop in production, that's just reality, all tools go dark instantly. Every single one. Not just the tools on one server, all of them. Because everything was routed through this one middleman. This is the toll booth anti-pattern. You built a bottleneck into your own system and called it architecture. Don't do this. Here's what you actually build, and look at how different this is. The hub is a service registry. If you work with microservices, think console, think Eureka. Same concept applied to MCP servers. The hub answers exactly one question. Who is available right now? That's it. That's the entire job. Look at this diagram. The agent connects directly to the servers. That thick green line, that's a direct SSE connection. Server sent events, persistent, streaming, no middleman. That's where all the actual tool calls happen. The hub, it's off to the side, thin dotted lines. Health check every 30 seconds. Inventory server, you alive? Payments, you good? That's all the hub does. And here's the key insight. If the hub crashes, those active agent connections survive. Because the agent isn't talking through the hub, it's talking directly to the servers. Hub can restart, rebuild its registry from state, and the user never noticed anything happened. Registry, not router. That's the principle. And let me make this concrete. Look at these two flows side by side. Left, the proxy mistake. Agent sends tool call to hub. Hub forwards to server. Every single call goes through this extra hop. The hub is in the data path. It's touching every request. Right, the registry solution. One GET request to discover servers. That's the only time the hub is involved. After that, direct persistent SSE connections to execute. Hub never sees another request until something changes. One GET to discover, direct SSE to execute. The hub never touches the tool call path. That's the architecture. Okay, next piece. And this one's important because it exposes a lie that's everywhere in the AI agent space. Static tool loading. Hard-coded server URLs in a config file requires application restarts to change anything. You want to add a new server? Restart. Remove one? Restart. Server misbehaving and you want to take it offline temporarily? Restart. That's not discovery. That's a deployment artifact. Someone typed addresses into a file and the agent reads them at startup. It discovered nothing. Production demands dynamic discovery at runtime. Agents must hot reload tools without dropping user conversations. A new server comes online, the agent picks it up. A server goes offline, the agent adapts. No restarts, no redeployments, no downtime. This is non-negotiable for production, and it requires the hub to actively manage server state. So how does the hub track servers? 3 states. Look at these. Attached, green. Server is live, tools are available, SSE connection is active. Everything's working. This is your normal operating state. Detached, yellow. Server is still remembered in the registry, but it's been taken offline. Maybe for maintenance, maybe it's misbehaving and you want to pull it out while you investigate. Tools removed, connection closed. But the hub remembers it. You can reattach it later without re-registering. Deleted, red. Completely removed from registry, gone. The hub forgets it entirely. And here's how it flows. Any state change fires a webhook to the agent. Agent tears down the MCP client, reconnects to the current set of attached servers, reloads tools. Full recovery in under 3 seconds. 3 states: webhook driven, sub 3-second adaptation. That's dynamic discovery. Now let me show you what this actually looks like in practice. Because theory is one thing, seeing it work is something else. Step 1. User asks, check stock for product A. Inventory server is attached. Agent calls it, comes back. 847 units. Perfect. Now, event trigger. Inventory server detached. Maybe maintenance, maybe it started throwing errors. Doesn't matter, it's detached. Step 2. Same user, same question. Check stock for product A. Does the agent crash? No. Does it hallucinate a fake number? No. It says, I don't have inventory tools available right now. Honest, clear, no crash, no hallucination. Step 3. Event trigger. Inventory server reattached. User asks again. 847 units. Recovered in under 3 seconds. This is the protocol working as designed. And it's impossible, completely impossible, with hard-coded static configurations.
All right, now we're getting into the
You
engineering
only get this
that
with
separates
dynamic discovery.
production from prototypes.
Look at the top of this slide. Per request connections. Every chat message. Connect, handshake, tool call, disconnect. 500 millisecond penalty every single time. And under 100 user load, connection storms. Your servers get hammered with handshake requests. Now look at the bottom. Singleton. Connect once at startup. Reuse for all chats. Zero overhead. Obviously better. But, and this is the part most people miss, a naive singleton breaks when servers restart or connections silently drop. The connection dies. The agent doesn't know. It calls a tool on a dead line, gets nothing. And what do LLMs do when they don't have data? They hallucinate to fill the void. That's your 3 a.m. bug. Everything was fine when you went to sleep. A connection dropped at midnight. The agent's been giving confident but completely wrong answers for 6 hours. Nobody noticed. So here's the production answer, and it's 3 pieces. Fast API lifespan. You create one connection at startup, you clean it up at shutdown. That's your singleton. Every chat handler reuses this same client. Zero overhead per request. 30-second heartbeats. You're actively probing connection health. Is this SSE line still alive? Can I still reach the inventory server? If it responds, carry on. If it doesn't, flag it. Exponential backoff. When a connection drops, you don't panic and retry 1,000 times. You wait 1 second, try again. Fail, 2 seconds, then 4, then 8. You give the server time to recover without overwhelming it. And here's the line I want you to remember from this whole video. The happy path is easy. Reconnection logic is where real engineering lives. Anyone can build connect and call tools. Building the system that gracefully handles dropped connections at 3 a.m. without hallucinating, that's production. Now zoom out. Everything we've covered fits into this 5-layer stack. Bottom, MCP protocol, the standard interface, the foundation. Layer 2, registry hub, knows who's online, never in the data path. Layer 3, dynamic discovery, attach, detach, hot reload at runtime. Layer 4, LLM integration bridge, OAuth proxies, format mapping between LangChain and your provider. Big enough topic for its own deep dive. We'll cover that in the next video. Layer 5, Lifecycle and Health. Singletons, heartbeats, back off. And look at what's written on the right. Each layer makes a specific type of failure recoverable. Systems cannot prevent all failures, but they can know exactly how to handle them. That's the design philosophy. Not nothing will break, but when this breaks, here's exactly what happens. And that's the whole picture. Registry, not proxy. Keep the hub entirely out of the tool call path. Agent talks to servers directly. Hub sits to the side. It knows who's online. It checks their health. It fires webhooks when things change. But it never touches your data, never routes your requests. Build dynamic discovery and lifecycle management on top. That's what makes it production ready. The MCP protocol is stable. The ecosystem is mature. The architecture patterns are proven. Now it's about building, not demos, systems. Full articles in the description with all the code, architecture diagrams, and trade-off tables. If this helped, subscribe. We are going deep on agent architectures, LangGraph, production patterns. Next video, we are tackling that LLM integration bridge layer. Drop a comment. What are you building with MCP? What's been your biggest headache? I read every single one. See you in the next one.